So this is CPM Precalculus Chapter 1, number 38. So 38 is related to the one before it because it says in the previous problem it appears that g of x and h of x are inverses of each other. Okay, so in problem 37 before it, this is how g of x and h of x are defined. Test this idea by completing the following compositions. So we're supposed to test this by looking at g of h of 4. So right now I kind of know inverse functions are like in the idea of wrapping a gift, and the inverse is unwrapping it. Okay, so I'm going to wrap 4 with h and then wrap it again with g. If it's the inverse, just kind of think about h is wrapping it and g is unwrapping it. What should be the output? Anyway, that's just what I want you to think about as we compute these. So when we're given a function with the input of another function, we kind of have to keep looking at the innermost parentheses. So let me change my color. So the innermost parentheses is 4, right? So h of 4. So on the outside we still have g. On the inside we now can look at h, but we're going to put in 4. So h with 4 is going to be 1/2 times 4 squared minus 2. Okay, so that's just plugging in h of 4. So this right here is h of 4. Let's simplify it. We keep g on the outside. 1/2, 4 squared is 16 minus 2. 1/2 times 16 is 8. So we still have g on the outside, 8 minus 2. So then we're left with g of 6. So g of 6, now we are just plugging in wherever we see an x, we plug in 6. So that's equal to the square root of 2 times x, so x is 6, plus 4. And that's equal to 12 plus 4. It's equal to square root of 16. That's equal to 4. Okay, so when we do part A, we see that when we put the input of 4, we get the output of 4. So that kind of makes sense, okay? Part C and D are going to look more into, part D is going to look more into that. But B is just asking us to do this again, but now looking at the input of -1. So h of g of -1. Okay, so again, we look at the very most inner parentheses, because we have 2 sets. So the inner ones is just telling us that we're going to put an input of -1. Into where? Well, into our function g. So h stays on the outside, and now we plug in into g, we plug in -1. So g is square root of 2x plus 4. So it's square root of 2x, but instead of x, we know we want to put in -1 plus 4. And that's equal to, keep h on the outside, 2, so square root of -2 plus 4. That's equal to h, my equal sign, h of square root of 2. And now I want to plug in h with input of square root of 2. So that's equal to, now I look at h, wherever I see an x, I'm going to replace that here. The x is square root of 2. So it's going to be 1/2 times x, so now it's square root of 2, squared minus 2. Okay? Square root of 2 squared, we know, is going to just leave us with 2, because the square root and the square are opposites and they cancel each other out. Minus 2. 1/2 times 2 we know is 1 minus 2. 1 minus 2 is -1. Okay? Again, when we plug in -1 as our input, look at our output. It doesn't matter if we wrap the function with h first and then unwrap it with g, or we wrap it with g and then unwrap it with h. We see that a pattern is whatever we put in the input there, right, comes out as the output. The same thing. Okay, so let's look at C. C is giving us g of h of -2, right? So that's just, again, g on the outside, h of -2. If you can't see it, you might have to write it and then look, but h is 1/2 x squared. So x is -2, so it's 1/2 -2 squared minus 2. So that's g times 1/2 negative, no, not negative 4, but positive 4 minus 2. Positive because negative 2 times negative 2 is positive. G times 1/2 of 4 is 2 is equal to g of 0. Okay, now you plug 0 now into g as the input. So g is just square root of 2 times x plus 4. But instead of x we have 0, so it's 2 times 0 plus 4. That's equal to square root of 4 is equal to 2. Plug in negative 2, we get positive 2 out. So that doesn't leave us with what we thought we might have. So part D. Part D is asking, did you get the same output as your original input to all the problems? So we did for part A. The input for part A was 4, and the output was 4. Part B, the input was -1, the output was -1. Part C, the input was -2, but the output was +2. So D, did we get the same output? No, we did not. Right? We did for 2 of them, but not for part C. What happened to part C? We got negative, not positive, right? 2. Oops. Got -2, not +2. What did I do? Oh my goodness. I lost. Oh, here we go. We got -2, not +2. Okay. So part E. Part E then says, if you use y equals to plus or minus square root of 2x plus 4. So the change here is the plus or minus. As the inverse for h of x, it may seem to resolve this problem. Right, because then it wouldn't matter if it was negative or positive. We're just going to have both positive and negative. The relation y equals this is not a function. Why is this expression not a function? So if we graph it, we can see right away. So here is the graph. If you remember, the square root of x looks like this, right? Y equals square root of x. This now is going to be multiplied by 2 and add 4. So that 4 shifts it to the left. That 2, remember, stretches it up, makes it taller. So our function looks like this, something like that. That is y is equal to positive 2x plus 4. And down here would be y is equal to negative square root of 2x plus 4. So why is this not a function? Well, remember if we take our pencil or our vertical line test, here it hits twice. So anytime we take a vertical line, here it hits twice. Everywhere we have a vertical line, it hits more than one time. So we can say this is not a function. Oops. It is not a function because it does not pass the vertical line test. It does not. The vertical line test. And we showed arrows there and there that some examples of where it does not pass, so this makes sense. Okay, so this concludes CPM Precalculus Chapter 1, number 38.